Great, go ahead.
Okay, so hi everyone, and thank you for coming to this session. This is my first time doing this co-chairing, and I appreciate Jessica, who's been doing this for I think a year, maybe a couple of years, and just me to get along with all those things that we should do. And I hadn't realized that it's kind of pretty heavy and strong work, but anyways, it's going well. And so I appreciate Jessica, and also I thank you what Barb has done and is still helping us with this. Okay, so our presenter today is Hyunok Choi from the State University of New York at Albany. She's an assistant professor there, and she has received her PhD in environmental health science from Columbia University at 2006. And she's been a postdoctoral research fellow in environmental health section at Harvard School of Public Health. And we are thrilled to have her here today. She is working as environmental epidemiologist, and her research interest is air pollution, asthma, childhood obesity, precision medicine, and systems biology. That is just great fit to our research group. Okay, Hyunok, I just handed it your way, and I will mute myself as well. I'm looking forward to hearing what you're saying. Thank you.
Thank you so much for such gracious introduction. Can you all hear me?
Yes.
Oh, great. Wonderful. I apologize that I am faceless. I don't have a webcam in my computer, but I could see all of you. So today's talk is focused on the susceptibility, in particular, of the girls to inhalational exposure to a class of very well-known pro-carcinogen called polycyclic aromatic hydrocarbons. And I'm going to focus on one particular compound within that class of chemicals called benzo-pyrene. Sorry? Did someone say
Sorry
something?
interrupting you, Hyunok. You need to speak a little up.
Okay. Is this better?
Yes, thank you.
Okay. Thank you. I'm sorry about that. So I focus on benzo-pyrene and the asthma outcome. Next slide, please. So this slide shows the secular trend of asthma on the left between 1965 and 2005, stratified by countries, and the prevalence of obesity stratified by age and gender, in which the red squiggly line represents the rates for women, and blue line represents the rates for men, and the one on top, two lines represent the developed countries, whereas the triangles represent the prevalence for developing countries. The only thing I'd like you to gather from this is that we are going through something of an explosion in both of these two diseases. And these two have traditionally been investigated as two separate diseases with presumably separate pathophysiologic processes. But a growing number of emerging body of evidence suggests that number of asthma sufferers also have obesity and or overweight status, and that those segment of population have particularly severe form of asthma that are also resistant to pharmacotherapies and other intervention measures. The second point that I'd like to make with this is that this something of an explosion has happened in such a short span of time. I mean, if you notice, this is not even 2 generations between 1965 and 2005. And that suggests that genes are not adequate as explanatory variables to account for this current explosion in prevalence for either the asthma or the obesity. Next slide, please. So to recap, this is actually the summary for asthma. The national prevalence of asthma ranges between 5 to 25%. In US alone, the cost of asthma care has been noted to be about $56 billion. But the true cost is likely to be much higher because we have not accounted for other uh, losses, economic gains and losses, such as loss of productivity, school absenteeism in this cost calculation. As of today, the treatment goals focus on the symptom alleviation rather than understanding the causal processes. And perhaps, at least partly due to this focus of symptom alleviation, the treatments are ineffective in more than one third of children and in about half of the adults. So, the overall goal of asthma research in our Czech asthma pathway study is to dissect the mechanism and better understand the causal processes according to the exposure and to subclassify asthma beyond that based on the phenotype so that we could develop a more targeted and specific clinical public health and community intervention strategies. Next slide, please. So if this slide actually is a little too basic for some of you, I apologize, but I wanted all of us to be on the same page. So what is air pollution? It essentially is any kind of a gamush in the air that you could inhale. And our eyes, they're so small, as you could see in the particulate matter with different size distribution. So we could not see particulate matter with aerodynamic diameter less than 10, which blends within the thoracic region of our lung. Sorry, the upper and the middle region of our lung. And more recently, the research has focused more on the particulate matter 2.5 that reaches the deepest part of our lungs, as well as the ultra fine particles, which is capable of infiltrating any part of our bodies, even the brains, without any troubles. Next slide, please. So this slide summarizes just a few known health effects of polycyclic aromatic hydrocarbons. It's a very classical carcinogen that's been known to exist since the Industrial Revolution and is a well-known component within the environmental tobacco smoke. So this little fuzz that you see in this black circle dot, actually this happens to be a diesel exhaust particle. So we're talking about when I say polycyclic aromatic hydrocarbon, I mean these chemicals that you see as a little fuzz that sits on top of the diesel exposure exhaust particles, and they get carried by these diesel exhaust particles to various regions in our lung according to the size of the particle. So the particles that are largest happens to land within the nose and the mouth region, whereas the more PM10 particles, the one that I highlighted in green, happens to land within the biggest bronchi of the lung, and more finer ones, at, and in the aerodynamic diameter less than 2.5, then the red rectangle ends within lands within the deepest part of our lung, alveoli and the bronchial within our lungs. And these polycyclic aromatic hydrocarbon are extremely efficient at forming an extremely stable covalent bond with our DNA, and does all kinds of things, one of which is that they are very mutagenic and carcinogenic, but at a much lower concentration in rats that were exposed preconceptionally, in order to model the preconceptional cigarette exposure. So rats that were preconceptionally exposed to PAHs through cigarette smoke were significantly smaller, shorter, and had smaller brains with hemorrhages. And placenta also is affected by polycyclic aromatic hydrocarbon. As you see on the two models of placenta, rat placenta, where the placenta on the right represents the PAH exposed placenta, which is much less effective in terms of delivery of oxygen as well as the nutrients to the fetus, compared to the normal placenta, unexposed placenta on the left. Next please. So in this slide, just to introduce you to what we're going to talk about, actually this is not our group. Our colleagues had conducted an experiment in Beijing by prenatally exposing a group of rats for 8 weeks to either filtered or unfiltered air. And they measured the body weight as well as the organ weights separately for the male versus the female rats. And they show that not only is the overall body as well as the specific organ weights higher in both the male and female rats, the increase in body weight is significantly higher for the male rats compared to the female rats. Next slide, please. They also measure the oxidative stress markers within various organs of the same group of rats, and demonstrated that those rats that were exposed to unfiltered Beijing air had significantly higher levels of malon dialdehyde as well as 8-isoprostane number of measured organs. Next slide, please. In a separate study, they had examined the differential effects of lung function according to the obesity status. By comparing the obese children to the healthy weight children after stratifying them by sex. And the bar on the dark bar shows the percent difference between the obese versus the non-obese children for percent predicted post-bronchodilation FEV1, and the one on the right shows the post-bronchodilation FEV1 over the FVC ratios. We see that the boys are significantly more affected by obesity in terms of their lung function compared to the girls. Next slide, please. So to recap, in this particular analysis, we conducted a case control study. And this was actually a very complex study. In this particular analysis, we focused on very specific 3 questions. First, we wanted to examine the utility of 3 systemic oxidant stress markers, namely the 15-FT2 isoprostane, urinary level of 8-oxo-DG, and protein carbonate concentration. I wanted to examine whether their behavior differs according to gender. Second hypothesis was that we wanted to test whether the effect, the risk of PAH on asthma differ according to the overweight obesity status as well as the gender. Final hypothesis we tested was that the oxidant stress biomarkers predict the sexually dimorphic susceptibility to asthma with PAH exposure. Next slide, please. So this is a case control study, which we enrolled 100 children from Ostrava, that particularly brown area you see on the right, which is a historically industrial region marked by metallurgical or power plant generation. And since the 18th centuries, I mean, has been an extremely polluted, one of the most polluted regions within Europe. Contrast, we chose the rural Prakatice as our control site. I mean, this is, as you see, a region right north of Austria, and the only known sources of air pollution there is the automobile exhaust and domestic home heating. Next slide, please. So from here on, we are going to talk about the results of the present case control investigation. You see here that the median concentration of benzoate pyrene for asthmatic and controlled children, in which I subdivided the asthmatic children according to the history of predictive asthma index. So predictive asthma index is a well-known index developed by Dr. Castro Rodriguez. And we see that children with a more severe form of asthma predictive index have a dose-dependent increase in median benzoate pyrene concentration. And this is a contemporaneous benzoate pyrene concentration, whereas the outcome is a history of modified asthma predictive index prior to age 3. That is clear. So next slide, please. In here, we compare the linear association in the the plasma level of lipid peroxide, lipid oxidant stress biomarker, 15-FT2, isoprostane level in all children stratified according to weight, obesity status, age group, that is the pre-adolescent versus the adolescent age group, as well as the gender. And we see that association between benzoate pyrene, the particular compound of a polycyclic aromatic hydrocarbon, and the 15-FT2 isoprostane association is overall null among the lean children. And we see the line going even, that is, the isoprostane level increases in lean girls, lean adolescent girls, as association is null in other groups. Contrast the overall and in obese children, the unit increase in benzoate pyrene was associated with about 15% reduction in isoprostane level among the pre-adolescent overweight these girls, whereas the similar association was about 1.3% reduction among the lean pre-adolescent girls. Next slide, please. This slide shows the median and interquartile ranges of the isoprostane level within plasma, stratified by age, gender, and the asthma outcome status. Overall association is very weak, but what we are seeing here is that only within overweight and or obese children, the level of isoprostane is lower, particularly among the pre-adolescent girls, as well as the adolescent girls, but to a less extent. Next slide, please. This slide shows the similar median and the interquartile range of the 8-oxo-DG, the urinary DNA peroxidation status biomarker. Not see a very clear pattern of association according to the age and gender. Next slide, please. When we compare the protein carbonyl, so this is a protein oxidative stress marker, also measured within, I think it was measured in plasma. So anyway, we again see that only within the only among the overweight and obese children, the asthmatic children had overall lower level of carbonyl concentration, and that association was perhaps most pronounced among the pre-adolescent children, pre-adolescent overweight and obese children. So, next slide, please. We attempted to put all of this together in a comprehensive multinomial regression model. So what you see is a series of models in which the children's health outcomes of interest are defined according to in 3 unit groups. That is the overweight to obese status alone. The second outcome is the asthma outcome alone. The third outcome is those children that have not only the overweight to obesity, but also asthma diagnosis. And we see here in Model A that unit exposure to airborne benzoate is associated with about 4.3 times greater likelihood, odds, I should say, of asthma diagnosis among the lean children. Asthma outcome alone. The same unit of exposure is associated with about 5.7 times greater odds of asthma among those children that have obesity, as well as asthma outcome. Next slide, please. Next. Thank you. We stratified the same children according to gender in this model, and again ran the same multinomial logistic regression model and in order to compare the size of the association for each of the separate outcomes according to children's gender. What jumps out, at least to me, the most is the fact that among the boys, the lean, the asthmatic children was most susceptible to unit exposure to benzoate pyrene, as they experienced 5 times greater odds of having an asthma diagnosis compared to lean healthy control boys. In contrast, the girls with morbid condition, that is the overweight to obesity, as well as the asthma diagnosis, was associated with 5.9 times greater odds of having these two comorbid conditions per unit exposure to airborne benzoate pyrene. Next slide, please. We then subsequently stratified the children according to not only the gender but also the age. We compared the risk among the pre-adolescent children as well as the adolescent children. So in the top 4 lines, we are using the lean control as the reference group, as well as in bottom 4 lines, we are considering the lean control as the reference group. So compared to the lean controls within the pre-adolescent group, log unit exposure to airborne benzoate pyrene was associated with the largest increase in odds of developing asthma among the lean children for the boys. As you see, it's 5.2 times greater odds of asthma among the pre-adolescent boys. In contrast, the same unit of benzoate pyrene exposure was associated with even slightly larger effect among pre-adolescent girls unit exposure. That is, unit exposure to benzoate pyrene was associated with about 5.8 times greater odds of developing this comorbid condition. We examine the adolescent children, see that there is something of a flip in the risk. That is girls happen to be much more vulnerable to unit exposure to benzoate pyrene compared overall to the boys. That is, unit exposure to benzoate pyrene was associated with about 15 times greater odds of having this comorbid condition, whereas it was associated, the same unit of exposure was associated with about 10 times greater odds of having the comorbid condition among the boys, among the adolescents. Next slide, please. So this slide puts it all together, and we attempted to better understand the source of vulnerability among the girls. And I mean, due to the space limitation, I'm only showing you the model that controls for the carbonyl levels as well as the lipid isoprostane level, as well as other confounding factors here, in which the children are stratified according to the pre-adolescent male, pre-adolescent female, as well as adolescent males and females. And unit exposure to benzoate pyrene was associated with largest increase in likelihood of having an asthma alone among the pre-adolescent males, whereas not see large difference in the odds of asthma among pre-adolescent girls. They have either asthma alone, morbidity of asthma as well, along with overweight obesity status. However, when we consider the adolescent children, risk of unit exposure to benzoate pyrene is associated with about 8.5 times greater odds of having the comorbid condition of obesity as well as asthma outcome. And the risk is even higher among the adolescent girls, that is, who are comorbid for the obesity, overweight status, as well as the asthma outcome status per unit exposure. That is, a unit exposure to benzoate pyrene is associated with about 15.3 times greater odds of having the two comorbid condition per unit exposure. Next slide, please. So what are we showing for the first time? We are showing that the adolescent overweight obese girls experience about 16 times greater odds of asthma per unit benzoate pyrene exposure. See a little bit less of a risk among overweight and obese boys who are also adolescents. So putting it all together, I mean, benzoate pyrene exposure is associated with a largest increase in odds of asthma among the overweight and obese adolescents, particularly after adjusting for the oxidative stress biomarkers. That is, after accounting for the effect of these three oxidative stress biomarkers, the effects of benzoate pyrene were larger. Next slide, please. So, what is my long-term goal? This is only the beginning of in our inquiry as to that in the middle biomarkers. So these are promising in the sense that they are not only associated with the exposure variable, but also the health outcome. we want to identify other related meet in the middle biomarkers that would have a prognostic value, identify predictive biomarkers, and test their utility in the future, only for the asthma outcome, but also those with comorbid conditions. Thank you. I could open the floor for any questions. Oh, before I do that, these are the very valuable members of our team that made all of this analysis possible. Dr. Bin Zhang at Mount Sinai and his junior colleague, Dr. Song, Dr. Yana Haislova on purple circle, as well as Professor Yana Prokorovova at University of Chemistry and Technology in Prague. Professor Shokmei Ho, as well as her junior colleagues from University of Cincinnati, are responsible for all the omics analysis, epigenetic, as well as the transcriptomic analysis. And this project could not have been possible without the unrelenting spirit of Dr. Radim Shram that you see in this 10 circle on the left. He began this as a Teplice project about 30 years ago, and it's still going very, very strong. That I could open the floor for questions.
Hyunok, this is Jessica. Thank you for such an incredible presentation. That was wonderful.
Oh, thank you. It was rough around the edges, and I really thank you for your patience with me.
This was profound. I actually I'll put my 3 questions out there and then put myself back on mute. The first is, tell us where this is going to be published because we're going to cite this. It's very relevant to a lot of our work. The second is if you could comment in a little more detail on how the benzo A pyrene exposure was measured in the environment. And then the third is those odd ratios are incredible. You know, to have 15.4 for an environmental exposure, working with US and Canadian populations, I rarely see that. But I also noted that confidence interval really widened on those groups. So if you could just comment on that and your interpretation.
So in answer to your very first question, this paper just got published in Environment International. So I think it's freely available right now. And I'd be happy to send it to you, your group, and disseminate. So please feel free. I would be most happy if we're useful in any way in your research. The second question was, I skipped the part about how we measure the airborne benzoate pyrene, but Czech Republic happens to be a unique country that has a truly remarkably dense and well-run monitoring program of not only the criteria pollutants, but also the air toxics, one of which is the polycyclic aromatic hydrocarbon. So essentially, I depended on the central air monitor that sits on the middle of the town square and use that as the proxy measure of personal exposure for all the children. And I admit that this is a very crude measure of personal exposure. We're right now trying to refine the exposure assessment for longer period and at a finer spatial scale. But in spite of all of this, the exposure was remarkably associated with, really significant odds ratios. So in regards to your final question, the third question about like how could it be that the odds ratios are so high here? Um, and I get asked this question a lot. Our best guess is that we are looking at extremely wide range of exposure here. If we, I, could we go back to the slides? Any chance, or is it gone?
Sure. I'll get them back up there. Just take me a second here. Let me know where you need me to go.
The slide number 10 for this. Yep, the map of benzoate pyrene. Yep, this slide. Thank you. So if you look at this slide, the concentration of many cities in the U.S. is about comparable to what people experience in Prakatidze. Whereas the concentration of pH in Ostrava is about 6 to 10 times higher throughout the seasons. So our best guess as to why we're seeing such a strong odds ratio is that, first of all, this is a case control study that might be inherently more likely to estimate higher odds ratio. But secondly, we are looking at a very small country with an intensively strong spatio-temporal variability in benzoate pyrene, as you see in this map. And this map actually does not even show the seasonal variability in benzoate pyrene, because this is an annual average. So seasonal fluctuation of benzoate pyrene has been kind of muted out, so to speak, in this map as an annual average. But the seasonal variation is even higher than that shown in this map. So that would be, the most kind of a plausible explanation that I could come up with as to how we could possibly be seeing such a strong and significant odds ratios in this population.
Thank you so much for such a great presentation and such an interesting and novel research topic. And I have a question. I know that you have to go, but I have quick questions, and then we probably have one more question. So how did you, maybe I ask it this way, how many times did you get the blood samples, and from how many samples did you get that? That's one question. And also my other question is do you have any suggestions of how the physiology of boys and girls is different that make them more prone to like benzopyrene than rest of the other gender? Or also, how do you think that would the obesity affect the vulnerability to the pollution?
Wow, those are very big questions. And I may not do justice in the next 5 minutes in answering your questions, but I'll try my best. The first question was how often we measure the blood sample, blood and urine. And these blood sample was measured in both the mothers and the newborns in about 700 newborns. We targeted 800 mother newborn pairs. We are slated to begin another study in this region for another additional 800 mother newborn pairs. But we measured the blood in the mother's ones, and the umbilical collected the umbilical cord blood. We will be measuring urine, as well as the saliva as the children grow, but not the blood. I mean, the parents are adamantly opposed to donating children's blood, as well as other biological samples. In regards to your second question, I'm sorry, could you rephrase your question so that I...
Sure. What do you think that is the physiological difference between boys and girls, and also in lean people versus the obese people that made them more prone to get asthma when they are exposed to, let's say, benzopyrene?
So that's too big a question for me to answer in this particular presentation, let alone in this next 5 minutes. But there is a really impressive emerging body of research that have shown that key hormones, namely the adiponectin and leptin levels, are profoundly different between the boys and girls, and that some of the anti-inflammatory effects that adiponectin has on not only the lung, has a spillover effect on other parts of the body, so that this may be what we are observing in this particular analysis. We also know that placenta is an extremely gender dimorphic organ, and that research is also emerging. It's still in its infancy. We don't really understand, but the way that the placenta interacts with the environment might be profoundly different. But it's a good question. I don't know the answer to your question.
Yeah. Thank you. Thank you so much. That was really helpful. Any other questions from our audience here? Okay, I guess that we don't have any more questions. Thank you so much for coming and being our presenter. We may approach you again, and we will be happy to hear more about your other research and other papers that you're publishing. Again, I appreciate you coming from all of our group members here. So just, again, thank you so much.
Thank you. Great meeting you all. Thank you.
Thank you. Bye-bye.